The nonmetals. The nonmetals tend to not be as similar as the metals are. Again, nonmetals can be solids, liquids, or gases. The solids will be brittle solids rather than malleable solids. Another thing that we'll find is that we are going to have some elements that are going to be diatomic, which means as an element they exist as a sort of as a Siamese twin or pair of atoms stuck together. And hydrogen, for example, is one of those, and the element hydrogen will always be written with a subscript 2. So there will be 7 of these elements, which I'll list as I go through them, and you need to be familiar with those 7 elements as diatomic elements. The nonmetals that you need to learn are hydrogen, and hydrogen is one of the diatomic elements. Hydrogen is a gas at room temperature. And then let's skip over to group 3. We have boron, which is a solid. We have carbon and silicon. Carbon and silicon are both solids at room temperature. Carbon is kind of interesting because carbon can exist in 3 different allotropes, and allotropes are different ways that the element, the pure element, exists. We have graphite, which is similar to pencil lead. We have diamond, and we have buckyballs. And you might want to look buckyballs up on the internet to see what they are. The difference in graphite and diamond is graphite is a planar or flat structure, whereas diamond is a 3-dimensional structure. Graphite, of course, is black, where diamond is clear. Graphite is soft. Diamond is extremely hard. So there are 2. Graphite and diamond are worlds apart, but they're made up of the same atom. It's the way that they're put together. Silicon is also a solid, and be careful, the element silicon. And then we have the compound, or the polymer, which has an E on the end of it. And this is used for things like breast implants. So be careful about putting the E on it because it makes a difference. So we have carbon and silicon. And then in group 5, we have nitrogen, and nitrogen is a gas at room temperature, and it's a gas that makes up 80% of the atmosphere. And we have phosphorus and arsenic, and both of these are solids at room temperature. In group 6, we start off with oxygen, which is a gas, and actually oxygen exists as allotropes because we also have ozone, where 3 oxygens can get together, and that has a special name. But oxygen is diatomic, O2. Sulfur and selenium are both solids at room temperature. And then finally we have group 7. Now group 7 as a group are called the halogens. And as a group, they have pretty similar properties, and I'll start on the other side of the periodic table to talk about those. Fluorine and chlorine are both gases at room temperature, and they are very reactive gases, and they both are sort of a greenish yellow color. Bromine is actually a liquid at room temperature, and it is pretty reactive, and iodine is actually a solid at room temperature. And it's a solid that actually sublimes a lot like mothballs do. But chemically, they have similar properties. And then finally, we have group 8. And in group 8, these elements are extremely similar. These are the inert gases, which means that all of these elements are gases. Helium, neon, argon, krypton, xenon, and radon. They're all gases at room temperature, and chemically they are almost totally non-reactive. So when you learn these elements, most of these nonmetals are important to learn. And so I'll go ahead and check off again the ones that you should be learning. Radon, by the way, is radioactive. And the diatomic elements are hydrogen, and then nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And so this is the way you'll see them on the chart. We've got our hydrogen here, and then nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There are 6 elements here, plus the hydrogen, which makes a total of 7. And so this sort of makes a 7 on the chart when you look at it. But these are the 7 diatomic elements.